what's up guys? Thank you very much for being an electric. I really appreciate that. Now I have videos here that are talking about float switch. Okay, so they are demonstrating different way how you can have your float switch control pumps in different modes. Okay, so the first segment here demonstrates how you can demonstrates in a whiteboard how you can operate a pump with two float switch. And this is usually done if you have two tanks. You have an overhead tank and you have a surface tank, or you have a sump. So you have a pump in the sump and then you have a surface tank. Now usually the float switch in the higher tank controls overflow, okay, and then the float switch in the lower tank controls levels, the minimum level in that tank, so that the pump cannot pump everything and then it sucks that air. So usually that's the theory. So enjoy this video. Now, there is a video we did about float switch, and we showed how to wire them, how to connect them, but still some people really needed a broad enlightenment on how the connection are done and also the circuit. Okay, so that's what we are doing here today. All right, now let's begin from here. We have here two tanks, and I would call this one A and I would call this one B. So this is an overhead tank and this is a ground tank. Okay, so you have a pump here that is sucking water from this tank and takes it to this tank, and then gravity will take this this water to the house or wherever you want it to be. Okay, now the ground tank here, it's being filled by the utility supply. Okay, so this water comes in freely it's pressurized, so it comes in from the utility supply. Okay, and then it fills this tank. Okay, now because you have this tank here on overhead, so you need a pump that will pump water there. Okay, so that you don't use the pump directly into the house. Okay, so you can save some bit of electricity. All right, now because we have a pump here, that's the reason why we have to employ this float switch. Okay, so this float switch are just switches like a normal switch you do have. Okay, but this one, yes, you can even call them automatic. When you connect this to be automatic, because it's hands free. Okay, so they are being operated by water. It's just a switch inside that it's being moved by a ball, that clicking sound you hear inside. So if you're interested to see what's inside, I'll leave a video in the description. Okay, so this float switch one can operate this pump here, but it will be very awkward to just connect this float switch directly to the pump, just the same way you connect your light. That will be really very awkward. It won't be sensible. So what you're gonna do, you need a contactor. So this guy here will operate your contactor, and then you have cables that will now operate your pump. Even if it was 30 meters, 40 meters, it now depends on the specification. It depends on so many factors. Could be also the length from where your pump is and where the tank is. Okay, and then how much water the pump is pumping per minute, how many cubic meters that it's pumping. Okay, so all that factor in to give you the specification of the pump that you're gonna use right here. Okay, so the float switch don't really bother you a lot, because you're just going to to carry a small current to operate this guy here. Okay, all right, now we could use one float switch right here and it will operate this pump. When the tank gets full, it flips. Okay, and the pump will stop. When the water goes down, it goes back to this position and it will run the pump. Okay, but now there are some scenarios that this pump is pumping water from here, taking it here. But some instances, if this tank doesn't have water and this pump is pumping endlessly, then definitely it's gonna, blow air, okay? And that's not the right thing for the pump, for the impellers. So that's why you need a float switch to put here such that it can protect this pump from that. Now, you set a threshold, and this threshold you set it by, you might decide and you might set it in such a way that if this water reaches this level, then this float switch will flip, okay? And the same way, if this water reaches that level, again, the tank, the float switch will flip and then switch over this. So each of these, either of the float switch can switch off the pump, okay, regardless what position the other one is in, because they are connected in series but in different positions, okay? Why do I mean by that? This float switch here, the way you see them, they serve two purposes in that position, because it has three wires here, a common red, brown, black. So this float switch, it can be in this position and it will be open, and it can be in this position closed. It can be in this position closed and open, okay? So it depends on how you connect it, all right? So in these tanks, you're gonna have them for the pump to run. It means that the float switch will be in closed position in that tank, and then this one will be in that position closed, okay? I hope you're able to see that, eh? So now the pump will pump. Now let me say that tank A loses water, so water has gone below the threshold. So the moment this one changes to this, then definitely the pump will go off. Remember, the other one was still pumping because it is in on position. This one, the pump will go off, okay? So if this water is restored to its position where you had set, then this one will flip back and the circuit will run. But again, if tank B gets enough water, then this one will flip like this and it will switch off the pump regardless which position this one is in, okay? So that's it. And the other thing we can talk of is that they are connected in series. Now you see the three wires that are here, we have a common brown and blue. So we're gonna, here we might cut out blue, and here we might cut out brown, okay? So you see, this side I'm running brown, black, here blue, black, all right? So what we do, we can connect, I know, one float switch gonna be like 30 meters away from each other, but you have to run the wires anyway, okay? So you're gonna have common connected like this, okay? The common wires. Now, if you're wondering how to connect this, so you're remaining with blue this side and black this side, okay? So if one contactor is in that position and another one is in this position, you see, that means that our circuit will be on, okay? So that means that here will be your incoming supply, maybe from your breaker, and then the power will run through the float switch, through the second one, and this will be the output. So this one will supply your contactor, okay? So if your pump has moved like has moved like 30 meters, 40 meters, 50 meters, 300 meters, whatever, that one, the float switch will have to run these wires. They will have to go back and forth to operate this. So that's not really a big problem, because you can use a bigger wire to take care of the voltage drop. So that's not an issue when you're dealing with this, okay? I hope maybe I've tried to explain everything, but in case I've left any other thing, please don't forget to leave, a note in the comment section down below. And there is a video we did on this very same topics, like 3 or 4 videos on the channel. So you are able to watch and come back and watch here. All right. You can also visit my blog at electricalsolution.com/blog, and then you can also find the same information there. Okay, link in the description. You can also follow me on Twitter at Sengedo-D. Feel free to do that. Link in the description still. So thank you very much for watching Electrica, and I'm glad. If you've not subscribed already, please consider doing so. I will appreciate. And don't forget to give me a thumbs up. If you don't like us, no problem. You can also give us a thumb down, but that's not what we're asking for. A thumbs up. Thank you. And I'm out.
Okay. Now, the second video, or the second segment, it's just demonstrating what we saw in the first segment, because the first segment was purely a demonstration circuit. Then the second segment is only showing you practically how you can connect those float switch in series to to control your pump. Okay.
What's up, guys? Welcome back to Electrica, and I'm glad that you're watching. Okay, now probably you've heard about high and low in float switches, okay? And today I just want to show you how you can use 2 float switches in controlling your pump. And doing this, we try to prevent our pump from sucking air, because the pump tends to suck air in most cases, okay? Especially if you have 2 tanks, one is overhead and there is one on the ground. So you have one tank on the ground that feeds the tank overhead, and then the overhead tank is what supplies water inside your installation by gravity. Okay, so you have one pump and you have 2 float switch. Now one float switch is gonna be in your higher tank, and then you will have one float switch in the lower tank. Now, the float switch in the lower tank, as I said, it will help you to prevent your pump from sucking air. Without it, the pump will pump all the water into the tank in the overhead, and it will never stop until that tank is full. Okay? But if you have this, should it happen that the pump is trying to to pump all the water from the tank, then that pump will be switched off. So you're gonna set a threshold, a certain threshold on the lower tank, such that every time that tank reaches that threshold level you set, the pump will be switched off by this. Okay, so as long as the lower tank has water, this float switch will always be in on position. Okay, and it's only this one that will always play off and on depending on the higher tank its demand. Okay, so let's go ahead and wire it. So now of course you're gonna need a contactor, one contactor like this one, of course, even if you don't have auxiliary. And when you're using this, you can decide if you need it with a push button or you need it with a float switch only. So we're just using a float switch only. Let's say it's what you want. Okay, and I'm gonna show you one thing with this multimeter. Now this float switch has got 2 wires, 3 wires in here. Okay, one wire being common, and then these 2 wires serves in 2 different positions. Now this float switch has 2 positions in its operation. This float switch can be in this position on, or at the same time it can be in this position off. Also it can be in this position on, at the same time it can be in this position off. Okay, so that's what we're going to use it. Now when we are connecting it, they are just going to be opposing each other. Okay, Now, for our circuit to close, we'll need this float switch to be in this position. So the other one will be like this, okay? So here our circuit will be closed completely. So this float switch will be like this, and it will be closed in a higher tank, and this one will be like this, closed in the lower tank, okay? We need it like this because the moment the water in the lower tank goes down at a certain threshold, then it will go like this, and it will switch off our circuit to prevent the tank from sucking air. And this one, it will be like this in open position, such that the pump can fill the tank. But the moment the tank is full, it will go back like this, and it will switch off the pump. So there will be no more waters that get into the tank, okay? All right, now, to know in which position, you have, of course, to hold your float switch and use a meter in case you don't know. So you have to put your meter in continuity, okay? Now you're gonna put one lead on the common, okay? And you're gonna lift the float switch like this, and then you're gonna try. So you see the blue, meaning that this float switch will be closed in this position if you use common and blue, and it will be open in this position if you use common and brown, okay? So it's just the same thing with this one. Now, so connecting it, what we are going to do, we are going to eliminate one wire in each. So we're just going to use this tape. Now we are just going to eliminate blue here, okay? And we are just going to eliminate brown here, okay? So you see, the other side we are using common brown, and this side we are using common blue, okay? Now we are just going to use this to help us to connect these wires together, okay? Now, of course, what you have to know is that these float switch, they will work in series, okay? We're just going to put them in series. So we have got a wire here that we are going to use as to supply us with power, okay? So the one thing we are going to do is we are just going to, you get this common and one wire on the other side, then you have to connect them together like this, and then we're just going to use this connector for protection, okay? And we'll just put it here in this connector. So I just want you to get the concept of how all this works. Now we are remaining with these. We've already connected here, so we need to get our live this side, and then we'll feed it here. So this supply cable of ours, we're just going to use the live, and we connect it here, okay? And then we also use this connector to help us hold it, okay? So we are remaining with these two wires, so that means that this will now be the live or the supply of our contactor L1 or contactor A1, okay? So we have to supply our contactor here. And then this is of course our neutral. So don't worry, this is the neutral, it's just because it's brown. Now here, okay, so essentially you've seen that our current through here, we get it from here, then it will come through this float switch, come back here, go through this float switch, and then it energizes this, okay? So now we're just going to power it up, and then we see what happens. Okay, now let me hold these two float switch right now, and this one here in my left hand, it's now our lower float switch in the lower tank, and then this one in my right hand is our higher float switch, so it's high. And as I'm holding it like this, you see our contactor, it's in off position, so that means that this is in off position. So I'm just going to flip it, and then we see. So you see, now here it means that our pump will be in the running position. So as long as there is water in the lower tank, this float switch in my left hand, it always remain closed. Okay? And then the one in the right position, it remain like this if the pump, or if there is still gap in that tank, and it always go off if the tank is full. Okay, now let me assume that your pump is running here exactly like this, and then eventually maybe your lower tank is not being filled, so the water has reached that threshold that you set, and now this float switch will go like this, and then you see, so the overhead tank or the higher tank is in on position, but because the water levels in the lower tank, they have gone totally down, so the pump has been switched off, and that has saved you from your pump sucking air. And this can really be a very big problem if you have a very bigger tank, very bigger pump. Okay, so hopefully you've been seeing this and you're wondering what it is. So this is a counterweight. When this thing gets into water, remember it is light, okay, it's less dense, so you have to add this counterweight such that this will force it to be like go into water, but of course it can't because it is less, so it will help you to flip it such that it can go in off position. Okay, all right, so that has been it. So hopefully this has helped you in one way or the other. So thank you very much for watching, and please don't forget to press that subscribe button and the bell notification such that YouTube can notify you every time we upload a new video. Okay, yeah, and don't forget to give me a thumbs up. All right, I'll see you in the next one.
All right, now let us look at the third segment. So the third segment, this operates your pump in two modes. Okay, so you have the manual mode and you have the automatic mode. Now the manual mode, you have to have a push button, that is start and stop, and then the auto mode will incorporate now a float switch. So you'll have a selector switch which will be selecting in between the two modes. So if you select auto, you'll be using a float switch which are operated by levels of the tank. When you're in manual mode, that one you have to press the button manually for the pump to run. Okay, so watch that video.
Now, let us explain a few things, okay? Now, in this circuit, you need this float switch, and you need these buttons and the selector switch. And the main component here is the selector switch. It's what we are talking about today. Now, this selector switch, as the name goes, it has three positions in it. It has the off position, which it has a off position, which could be in this line. Then if you turn it here, that's one position, and then that's the second position. So if it's in the middle, that's a neutral. Okay, all right, now let's just understand where we need to use these. Okay, now I tried to start my circuit, and you saw what happened. I one time used a float switch, and the one time used these buttons. Now, take a situation whereby you have a pump and this float switch is in overhead tank, okay? And of course, overhead tank is maybe on your roof top, or it might be suspended some meters from the ground, okay, using towers. So you have this float switch in there, and it's the only one that starts the contactor. But just imagine if you need to maintain, or if a float switch has a problem and you need to repress it and you need water at the same time. So what do? Okay, so that's why you need to put these extra buttons on your panel. So in that, you use this selector switch now to select between these two switching positions. We have one switching position is in the tank, and we have the other switching position on the panel. But you have to use, because they cannot work both of them at the same time, okay? It's one at a time. So you use a selector switch to switch between them, okay? That's what we saw in our introduction. Okay, now as usual, you have a contactor, you have an overload, then you have a this you have this is and you have a float switch. Okay, but this of course can work with other stuffs. It might be a level sensor, just a real sensor, a level sensor, anything like that. It might be electrical valves, okay? Yeah, anything like that. It can still go with this circuit, okay? All right, now I want to show you a circuit, and then you get to know, because it's very good to learn and understand the circuit, okay? Now, in this circuit, hope you're able to see it very well. Now, in this circuit, the one thing you see is you have this little guy here, and this guy could be your fuse or your breaker, because in your control you must always fuse it, or you have to put a breaker for protection, okay? Now you have an overload here. This is a symbol of overload. That's what we always use. So which is this, your overload. We've done that several times. Check out a video, the link in the description. Now this guy here is this selector switch, and the selector switch has got two open contacts, and the two open contacts are just these push buttons. The green, the start push button, is you only get two of these, and then you hook them on this plate, okay? Now you're able to see they are normally open, both of them. So the difference between this push and then the selector switch is that the push is spring loaded. Okay, you only push once and you release and it goes back, okay? But the selector switch, it is fixed. If you turn it in one direction, it will stay fixed, you see? So one side will be in and the other side will be out, okay? So they do exactly similar jobs, but it is fixed, and then this is spring loaded, okay? All right, now here, as I was telling you, it is this, okay? And we have two normally open contacts, which is this. So this is the selector switch. Now we have two lines. You've seen we have this line here that are coming out from one side of the selector switch through a float switch and then to the coil. So the float switch is connected in series with the coil, okay? Because now it acts as a switch, just a typical switch, the one you use in your house. Okay, the other one takes the other line, okay, and this is the self-holding circuit. We've done that before. We've done the self-holding circuit, how to make it. We've done the star delta starter. All those, they use the same method, is the self-holding, so you know how to do that, okay? So from that side, you go through the normal stop, and then you make a holding circuit, you go through the start, and then you go to your coil, okay? So you see now they are both open, and if you look here, you see, okay, now there, if you look there, in there, they are both open, but if I turn one side, you see one green stuff move like this side, and then when I turn like this,
the other one also moves. Okay, you see? Yeah, like that. So when you turn one side closes, and then we use the button to start our pump. When you turn the other side, this opens and this closes, then we are able to control our pump using the float switch. Okay, and then this is a coil. A coil is inside the contactor, and then these are contacts where we use self-holding, which are these. Okay, all right, now let's wire it practical as you fall, and then we see what results we achieve. Now, I've already showed you the circuit. You can pause the video, look at it, and that's it. Okay? All right. Now, the first thing you need to do is to connect your overload. Okay, so you got to open here and then put okay, then the other side of the overload also. Now this wire from the overload will enter our selector switch. That's the first thing. Okay, so you open our selector switch. Now, because we have two contacts that we're gonna use, so we have to short. We have to loop here. And then here also. Okay, now we have two contacts here. One will go to the float switch and one will use the buttons. So now let's begin with this. Okay, now remember, red start, red stop, green start. So we need to feed red first. That's it. So you have to loop this side between one side of red and then the one side of green. Okay, now you need one wire, so you need to connect this side. This will help you to hold your circuit, and this side will help you to start, to give you the initial start of the circuit. Okay, so let us connect this side first. And then this is your holding line. You have to connect it here. Okay, make sure it's tight. So we have one side here. This will give us our initial start. So you're gonna connect here. So this is the other side of the start. And then you put this one here and you get this, a piece of wire. You connect it here such that it is able to supply our coil. Okay, so this, you see, now will now enter here. All right, now let's bring in our float switch. Now the float switch is now the other easiest part. Okay, now the remaining here contact of the selector switch, we'll just put here one side of float switch, because remember the float switch is connected in series with the coil. Okay, and it is in there. Now this will go directly to the coil, so there are two wires here. Now, one last thing you have to do is to connect the neutral. Okay, so the neutral is here. This is A2. So you put your wire here. So let's power it up. Now you've followed our circuit. You have followed our circuit very well.
our float switch just from one side of the selector switch here, okay, and then through the float switch to the coil. That's what we've done, through the float switch to the coil, okay. And then the other side of the selector switch, we've made a self-holding circuit through the stop button to the self-holding, and also through the start, and then to the coil, okay. So very simple circuit, okay. All right, now let's see what happens. Now I need us to hold this in this position, okay. So let's see. Now here it's in neutral, so we turn it one side, and then let's see. Now we're using the buttons, and now our circuit is able to start, okay. Now you switched off, you can start, put it off. Now we want to use the float switch, because now the float switch is here. You see, it can't engage the circuit. But if we turn the selector switch to the side of automatic or to the side of the float switch, it will work. You see? So this guy here is gonna be in your overhead tank, and then this guy is just going to be on your panel with this, okay. Now if it is in neutral or zero, it won't start even if you press here, even if you operate your float switch, okay. Now this circuit is very much suitable for you to operate your pump, okay. Some of these things are very cheap. You can, you know, have a full wiring of your panel, and then you're good to go, okay. Thank you very much. I really appreciate that you're watching the videos, and thank you for subscribing. I really appreciate that. If you've not subscribed yet, please push that subscribe button and push the bell notification, so that every time we upload a video, we notify you. And that has been Electrica. Have a blessed one.
All right, now in this last segment, this video is about what's inside a float switch. So in most cases, if you're troubleshooting a problem or you want to know if this float switch is faulty, it's very easier if you really know how the part works. So because this stuff is concealed, but in this video, we at least demonstrated how the inside of this float switch and how it works. So at least you have a picture, okay? You understand.
Hey, what's up guys? Thank you very much for being on Electrica, and I thank you for subscribing to Electrica. Now, today I still have a float switch in front of me, but as the title says, what's inside here? Maybe probably you've never bothered to look inside. Perhaps you're interested to know what's inside, okay? So we've done several videos about how this float switch operate, okay? So we did. I'll link a video in the description below. I'll also link it in the card probably now, okay? So I took time. I cut this, and then you know, I want us to have a look at it. This float switch is well insulated. It's a double layered, because now this is a plastic, then they had to wrap this one, because inside we have electrical switch that it shouldn't, you know, get water inside. If it gets any water inside here, obviously we'll have some short circuit here, and the switch will die out, okay? So I have a piece here that we have cut, and we simply want to, you know, I want to show you how it works and how it looks inside. Now inside here we have got this ball here. It's a bearing, okay? It's really heavy. It always stuck, but it can't. It's not easy to start because it's really heavy, okay? Then this is the latch. It's the switch that being moved by by this bearing. Okay, we have a switch right here. This switch is actually the same as these microwave switches. Okay, so you have ever seen a microwave switch and this one, there's no difference. Sometimes what matters is the current, but this is just, you know, the same. If you look at this came from a microwave. Okay, yeah, so it's just the same thing that they use here. Okay, so here we have got 3 contacts, right? We have brown here, we have blue and black. Now if you look here, black is common, and then we have on, you know, on, black is common. Now I told you in my earlier videos that this float switch, it operates in 2 different positions. Okay, for example, if this float switch is in this position, it can be on and at the same time off. I mean, it can be on or off. It depends on how you're going to set it. And if it is in this position, it can be on or off. So that's the reason why we have all the 2 wires, the blue and the brown wire. They can all put the circuit on, but it depends, or off, but it depends where the float switch is pointing. Okay, all right, so I can show you now. What happens is normally this switch will be like this. Okay, it will be like this. Just okay. So it will be just exactly like this. Now when you push here, you see that the arm moves the switch. Okay, you're able to see that the arm moves the switch. Okay, so the moment you move that, now when we put our ball right there, so if you put it upside down, as you hear this, it will just move up that side and then it moves the arm. Now if you put it the other way around, it will run here and now this will be pushed back. It's the switch, this, because the switch is spring loaded, so the moment the ball moves, it will push the arm back. Okay, now if the ball lies here, it will push the switch inside. Okay, so the moment the ball comes back, the lever comes back also, and the circuit will be open. Okay, so it's just the same thing. It's still the same thing the other way around. So right now, in the way I'm holding this piece of switch here, you see, if right now this knob is out, the way you're seeing. Okay, so if you test between the common and one of these, you'll find that one will be open and then the other one will be closed. Now for example, this will be open and this will be closed. When I press here, this one becomes closed, this one becomes open. Okay, as I'm pressing here, this is closed, open. When I release, you know, it swaps. Okay, so basically that's how you know, that's how it works. Okay, and there is absolutely no difference between these microwave switches and the one that are here. And the good thing is that these switches, they rated now, exactly this one is rated at 16 amps. Yeah, if we look at this, it's also 16 amps rated, same as this. So 16 amps is really huge. That's why you see that in most cases, most people can connect the thing, you know, just in series with the pump, of which it's not really that advisable to do so. Okay, it's not really that advisable to do so. You always have to use a contactor, okay? I always emphasize on that. You always have to use a contactor for you to be able, you know, to not to burden this thing quite a lot. So you just let this operate the contactor, and then the contactor will bear the other load indeed, okay? So,
all right, I thank you very much for watching this video till the end. You know, if you watch till the end, please give me a thumbs up. You can also subscribe and like and share. Thank you very much for watching. Until next time, I'm out.